Okay, guys, let's take a look at what's called a chain rule. But this is not a regular chain rule because what happens here is that we have a function of x and y, but x in turn and y in turn also depend on t. So you can think of it as either time or just a parameter, okay? So it's not the same thing as the regular chain rule. The way you remember this is you could draw the following diagram. So first you're going to start with z on the top. Okay, so you're going to put z on the top. Then you're going to say, okay, well, z depends on x and y. So you can draw that. And then you can see that x depends on t. So you're going to draw another branch here. And then y also depends on t. So that's where you draw another branch. And then what you do is, starting from the top, you're going to take the partial derivative of z with respect to x. Now, because z has two variables, right? It's a function of two variables. The notation should be the partial derivative. So it looks like a Greek letter delta or whatever it is. But it's partial derivative of z with respect to x. So why is this weird symbol? Because z does not just depend on one variable, it also depends on y. And then on the other side, we're also going to have z partial, but this one with respect to y. Okay, then we are going to start going down the tree and taking the partial derivative of x with respect to t. But because x depends only on one variable, this would be a regular notation. So we're just going to draw like a regular letter d. That's because x is only a function of t. And same thing is going to be over here. So dy over dt. All right, so if we want to find dz over dt, we're going to have to follow the branches, and then we're going to add up the answer. So what do we mean by following the branches? So we're going to multiply, it's going to go like that and multiply these partials. So this is going to be dz or delta z, delta x, multiplied by dx dt. And then we're going to also follow the other branch to get to t, right? Because we're taking the derivative with respect to t. So that's going to be plus dz, or actually delta. Oops. Okay, so delta z delta y times dy dt. Okay, so that's basically the formula, but now we have to fill out all of the pieces, okay, and substitute there. So let's start with talking about the actual function. So here I have z, and it is x squared minus 8xy plus 9y squared. Okay, so first I need to find the partial derivative of this thing with respect to x. So the first thing I do when I do that is I'm going to highlight the terms that have x. So this term has x, this term has x. The other term does not have x, so when I take the derivative, it's going to drop out. Okay, so I don't have to worry about 9y squared. It will go away because when you take the derivative with respect to x, you treat y as a number. Okay, so derivative of x squared, that is 2x minus. Now here you have to think 8 is a number, but also y is a number. So think about this as 8y multiplied by x, where 8y is a number. Okay, so just like 8x derivative is 8, 8yx would be 8y. Okay, so that's what's going to happen over here. Okay, so let's see if we can start filling this out. Okay, next we want to take the derivative of z with respect to y. So let me get rid of the highlighting here because I only want to highlight the terms that have y now. Okay, so this term now has y and that term also has y, but the first term does not, so that's going to drop out. Okay, so negative 8xy. So 8 and x are now numbers. And derivative of number y is the number. So that's just going to be negative 8x. And then the other one would be, well, y squared is 2y, so will be 18y. Okay, so that's going to go in here. Oops, not here, over here. Okay, so next we are going to take the partial derivative of x with respect to t. So let's do, actually that's not a partial, that's a regular derivative, right? So this is not a partial, this is just x with respect to t. And so that's going to be derivative of sine is cosine. So this is going to be cosine 5t. And the 3 that was in the front will stay there because it's a constant multiple. And also because of the chain rule, we have to multiply by the derivative of 5t, which is 5. So that's going to give you an extra 5. So this will be 3 times 5. So that's actually going to be 15 cosine 5t. And let me also do the derivative of y with respect to t, but there's only one variable. So to make the long story short, that's going to be 25 sine 5t, except if you remember, if derivative of sine is cosine, derivative of cosine is negative sine. So this is going to be negative. Okay, so that will go here and over here. Okay, so then we need to figure out this whole derivative thing. Okay, so we're gonna have to follow the branches, right? So we want to find what is the derivative of z with respect to t. Now this one is not partial because if you think about if you were to substitute x and y in for x and y in the formula, you will only have a function of t, which by the way, there's another way to find this derivative is actual substitution. Like if you were to plug 3 sine 5t for x and 5 cosine 5t for y and simplify all of that and then take the derivative, you should get actually the same thing that I'm going to get right now using chain rule. Okay, so what is it going to be? So I have to multiply dz dx. Okay, so this one is going to be 2x minus 8y. Multiply that by dx dt, right? So remember, this is what I had over here. So this is like dx dt. So that's going to be 15 cosine 5t. Why did I put 15? Cosine 5t. Okay, then plus the other derivative, so negative 8x plus 18y. Multiply that by that negative 25 sine 5t. Okay, so we are not done. Why are we not done? Like, we can actually think that, okay, well, that's the derivative, so what else do you want from me? Well, what I want is this thing should not have any x and y in it, okay? Nothing, because this is going to be a function of t only. So what do we have to do? We have to plug in for x, we have to plug in 3 sine 5t, because that's what it was. So we're going to have 2 multiplied by 3 sine 5t minus 8y, and y was 5 cosine 5t. Okay? And then that's multiplied by 15 cosine 5t. Isn't that exciting? Okay, then plus negative 8x, so negative 8 multiplied by x, which is 3 sine 5t, plus 18 multiplied by y, which is 5 cosine 5t. Okay, so what did I do? Instead of x, I plugged in what it was, 3 sine 5t, right? So where I saw that. So here and here. And then instead of y, I plugged in whatever it was, like this one, right? Here. And that's how I got this. But hold on one second. I still also have that negative 25 sine 5t. Okay. Well, if you are up for entering this huge thing into the blank, go for it, because I'm not sure it's going to count it as wrong, but I am actually going to start simplifying this thing. Okay, so as much as it pains me to do that, I am going to do it. So, because I'm very strong, I'm a strong woman. Okay, so here I've got some distributing here. So I have 90 sine 5t cosine 5t. Okay, minus. Okay, this is going to be 8 times 5, which is 40. Multiply that by 15, so that's 600 cosine squared 5t. Okay, then I'm going to multiply this way, which is going to give me plus. So that would be 8 times 3 times 25, which is also 600. Yay! And then that's sine squared 5t. And then minus, okay, 18 times 5 times 25. Minus 2250 sine 5t cosine 5t. So these two terms can be combined because they have the same sine 5t. So I got negative 2160 sine 5t cosine 5t. Now, what I don't like is I thought that this thing would cancel out, or at least we would be able to factor out 600, but I do not see that happening. So I don't know. Let's put that in there and see what happens. Oh my God, it's correct.